This is taken from your revision paper, page 11, question part 2. I don't know what question it is, okay? You can go and check it out. Now, given that 3 plus 2 square root 5 is a root of the equation, this equation, where m and n are integers, find the value of m and n. Okay? So if you were to read this question, the question is telling you that this value, okay, which is a value with surds, is a root. What does it mean by a root? A root means a solution of this equation. Now, what do you mean by solution of this equation? It means that when you solve this equation, okay, the variable that you're solving here is x value, all right? The x value, when you solve this equation, okay, the answer is 3 plus 2 square root 5. One of the answers, okay? There should be two answers because this is a quadratic equation. So if this is a solution, that means this is an answer for this x value. When you sub in this into here and here, the left hand side of the equation should be equals to the right hand side of the equation. Okay? So this is what you are expected to do. You are supposed to sub this into this equation, replace all the x with 3 plus 2 square root 5. Alright, now after you have done this, you will find that this equation is left with two unknowns, m and n, and they tell you that m and n are integers and they ask you to find m and n. Now this statement is very important because it tells you that your final answers for m and n cannot be a fraction, cannot be a decimal, it has to be an integer. Alright, so this serves as a check to see whether later your answer is correct. Now, what we need to do now is to expand this first. So in order to expand this, take note, it is not 9 plus 4 times 5. There is this term here that many of you always miss out. So take note, I'm just going to write down what so-called rule we are applying. Okay, we are applying this rule, this square plus this square, then in between there is a this times 2. Okay, so this is the algebraic rule that we are applying here. Square this times 2. Okay, whereas for this is a normal expansion, 3 times m, then m is a number, it's not a surd. So you just take the number times number, so it's 2m. Leave the surd alone and leave the n alone. Now after this step, many of you might be confused what to do. You have to group all the ordinary numbers together and all the surd together. Now where are all the surds? The surds are all here. These are the surds, or the terms with surds, okay? The rest are all numbers. So I'm going to group all the numbers 9, 20, so it's 29, 29, plus 3m, this is a number, this is a number, this is a surd, and this is a number, so this is what I have for all the numbers. And for the surds, I have 12 square root 5 and 2m square root 5. So I'm just going to take out the common term, which is square root 5. Okay, now what do I do after this? You have to now understand that this has more or less become like an identity. Okay, so this part here, not really an identity there, but you know this plus this is equals to 0, right? That means this ordinary number part, they must all add up together and be equals to the right hand side here, which is 0. Okay, because there's nothing on the right hand side, so it must be 0 for this. That's your equation 1. Similarly for all your surds, because the right hand side, the value of the surd is also 0. You see, it's actually 0 square root 5 plus 0. Okay, because this whole thing is 0 on the right hand side. So if you have to look at it, the other equation that you can form is 12 plus 2m equals to 0. Alright? And from here, you'll be able to get m equals to minus 6, and then you sub it inside here. This will be 29 minus 18 plus n, and you will get 11 here plus n equals to 0, so n equals to minus 1. Okay, so both m and n are integers, so very likely that you're correct. Okay, so please check whether there's any mistake. Okay, then you can get these two answers if there's no mistake.